4.2 Magnetic fields of electric currents. A electric current may also set up a magnetic field. Electromagnets are used in earphone, motor, loudspeaker, and many other daily electrical appliances. Part 1. Magnetic field patterns of electric currents. Let's take a look of the following experiment to see how different electric current configurations may produce different magnetic field patterns.
Switch on the supply and sprinkle iron filings on the board. Tap the board gently with a pencil and observe the pattern produced. Remove the iron filings and use a plotting compass to investigate the magnetic field pattern. Move the compass around the wire and note the direction of the needle. Wind the coil of 5 turns through the 2 short slots of the perspex board. Fix the perspex board on the power supply. Study the magnetic field pattern using iron filings. Then use a plotting compass. Wind the long coil of 20 turns through the 2 long slots of the perspex board. Fix the perspex board on the power supply. Study the magnetic field pattern using iron filings. Then use a plotting compass.
In all these experiments, we show different magnetic field patterns by sprinkling iron filings around the current-carrying wire and then tap the board gently. A. Field pattern around a long, straight wire. It shows a circular magnetic field pattern with the wire as center. The direction of magnetic field is given by the direction shown by compasses around the wire. The right-hand grip rule for straight wires helps us remember the direction of magnetic field lines. If the current reverses in direction, the field lines will also reverse in direction. The magnetic field at any point is always tangent to the circular field lines, and thus perpendicular to the radius. And the field strength becomes stronger when a larger current flows. To represent the 3D situation on a 2D paper, dot and cross are used to represent out of paper and into paper directions. The 3D diagram on the right is the same as the 2D diagram on the left. B. Field pattern around a circular coil. The diagram shows the magnetic field produced by the coil of wire carrying a current. The field lines near the center of the coil is almost parallel. Field pattern due to a solenoid. The field pattern produced by a solenoid looks like that of a bar magnet as on page 163. The right-hand grip rule for solenoids may help us remember the direction of field lines around a flat coil or a solenoid. Solenoid is often used as electromagnet in daily appliances. We may increase the strength of a solenoid by increasing the current or density of turns, or by inserting a soft iron core or steel core through the solenoid. When an iron core or steel core is inserted into the solenoid, it will be magnetized by the magnetic field to produce an additional magnetic field, called induced magnetic field. Hence, the resultant field becomes stronger. Soft iron core is so called because the induced magnetic field disappears as soon as the external magnetic field disappears. On the other hand, steel retains part of its magnetic field even when the external field disappears. In example 2, the magnitude and direction of magnetic field of a current carrying solenoid are investigated. The actions of steel and soft iron are also compared. In example 3, the magnetic field patterns of different current configurations are examined. Now try check point 2 below.